NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the red planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements and gathering data about the planet for more than 10 years. And good old Curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kind of expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of a dried-up lake and all that sediment and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now, a spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is Cacao, and it's about the size of a small car, 6.5 feet long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, so that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while Cacao is metallic-looking and dark gray. It's rounded and smooth, too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars, too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with light-colored material surrounding them. And the cool thing is that these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way the winds blow. But back to our buddy, Curiosity. It's been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why, though, and of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. Now, this doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of life a long time ago. Curiosity discovered potential evidence that there might be a large reservoir of liquid water beneath the south polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars, because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, there are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So, yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. Now, it's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So, you never know. There might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time. And one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars's atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space. So Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the red planet back in its old times. There's this story about an ancient megaflood that might have happened there. So yes, the red planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this megaflood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water, too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that?
And we have liftoff off of Mars Global Surveyor as America begins its journey back to the red planet.
There's a weird structure on Mars, a square, a near-perfect square standing alone in the endless red desert. And it looks too perfect, too precise to be anything but artificial. Nature's chaotic, and it rarely makes things look so deliberate. So the internet took one look at it and lost its mind, as the internet tends to do. The image spread like a virus on social media, igniting every conspiracy theory you can think of. Some were convinced it was proof that intelligent life had once tread upon the Martian sands. Well, let's dive in and sort it out. The image is real, and it's really old. The thing, not the picture. NASA's Mars Orbiter camera snapped it in 2001, capturing a tiny slice of Martian terrain, and there sat the square. Now, is that evidence for intelligent life? Well, Mars is an empty world now, a rust-colored desert. But once, long ago, it may have been something else entirely. A planet filled with roaring rivers, vast oceans, and thick clouds rolling across the sky. Now, in a world like that, life, if it ever had a chance, could have taken root. And there's a possibility it did. Scientists think that life could have existed on Mars in a short period from around 4.1 to 3 billion years ago. It could have started during the early era of Martian history, called the Noachian period, and lasted all the way to the late Hesperian period. Meanwhile, here on Earth, the first oceans were just forming. Life on our planet was just beginning, in the form of tiny bacteria in deep-sea hydrothermal vents. While Mars was already fully wet, on Earth, there were no plants or animals, just microscopic life trying to survive. So, Mars took the lead in the life game. It had a much thicker atmosphere, which could have trapped enough heat to keep water liquid. Valley networks, huge traces across the red landscape, show us the incredible story of rainfall, rivers, and lakes. Huge asteroids were still hitting Mars at the time, and they could have brought organic molecules with them. But if that's true, what happened, and where did life go? A recent NASA study suggests that the answer is more complicated than we thought. Astronomers believe that something drastic happened to Mars, like boom, and its cozy climate was gone, its atmosphere thinned. Without a strong magnetic field like Earth's to protect it, solar radiation stripped away the air, leaving Mars cold and dry. The ocean simply evaporated. Some of the water escaped into space while the rest froze underground or became locked in polar ice caps. Today, all that remains is a ghostly memory, dry channels and salty mineral deposits. But it looks like the transition wasn't sudden at all. It was slow and gradual. The planet was changing from wet and warm to cold and dry over millions of years. In fact, Mars kept its ocean even after the temperatures dropped to freezing. Some parts of Mars, especially the northern lowlands, might have remained wet for many, many centuries. Shouldn't the water freeze when it gets below 32 degrees Fahrenheit? Well, yeah. But there are many reasons why this miracle happened, like Mars's thick atmosphere and warm water traveling through currents. And during that time we mentioned before, from Noachian to the late Hesperian, life could have found a way. Microbes on Earth thrive in some of the harshest places, beneath Antarctic ice, in deep sea vents, in toxic volcanic lakes. Hey, life doesn't care. So these times in Martian history would be amazing for it. But don't be mistaken, Mars was never a paradise. Even during its cozy times, it wasn't as lush and green as we might imagine. In its early days, Mars was something more extreme, something closer to the young Earth. During the Noachian period, it was warm yet wet. Then, the climate shifted into the Hesperian period. Oceans were stretching across the northern lowlands. Temperatures dropped, and snow piled high, forming massive glaciers in the south, transforming the planet into an icy world. Finding microscopic life at that time is possible, but an intelligent civilization? That's less likely. The square that went viral isn't evidence for intelligent life yet, and here's why. First things first, people freak out because nature doesn't make straight lines. But that's not really true. Actually, nature does it all the time. For example, here on Earth, we have the Giant's Causeway in Northern Ireland, a beautiful field of hexagonal basalt columns. These are completely natural. They're formed by volcanic activity. There's also the Devil's Tower in Wyoming. Hey, remember it from the Close Encounters movie in the 80s? That's a symmetrical rock formation, and it was created by erosion. However, if we looked at these things from space, they'd look artificial. So, what is the square? How about a fracture pattern in the rock or some terrain that's broken apart along straight lines due to stress? This happens on Earth all the time when rock expands and contracts over time. And on Mars, The surface is just constantly battered by meteors, winds, and extreme temperature shifts. No wonder rock would get stressed. What happens here is another case of pareidolia. It's our brain's favorite thing, to spot patterns in something random. Hey, we evolved like this. So sometimes we might look at natural objects and see insane stuff. Faces on trees, animals in clouds, shapes, and so on. Besides, NASA has been photographing Mars for decades. We have high-resolution images of craters, mountains, valleys, riverbeds, everything. Wouldn't an ancient civilization leave us, well, something better than some square-like rock? Even though things erode over time, we'd find more signs, roads, foundations, artifacts, ruins, or at least something. Though, to be fair, we do see something. The square wouldn't be the first time Mars has played tricks on us. Over the years, we've spotted everything from tunnels to carved faces, even Bigfoot. Or this doorway, for example, a perfectly cut rectangular opening. That's what people saw when NASA's Curiosity rover sent back an image of the East Cliffs on Mount Sharp. It's almost like an ancient passage leading deep into the surface. You just need to go in and find some fantastic underground base. Well, NASA decided to take a closer look at it. It turns out it's just 12 inches tall and 16 inches wide, the size of a dog door. That's because what we're looking at isn't a doorway, but an open fracture, a break in the rock that happens naturally over time. These kinds of cracks are extremely common, both on Earth and on Mars. They form when bedrock is stressed, expands, contracts, or gets eroded by wind and time. If you walk through a desert here on Earth, you'd see plenty of similar shapes. Canyons, cliffs, and even boulders have fractures that, from the right angle, might look like doorways. They're just not getting photographed by NASA. Also, the straightness of lines turns out to be just a trick of perspective. If you zoom out, you'll see that it's just one small break in a much bigger rock formation. Or the infamous Cydonia face. The photo was taken back in 1976 by NASA's Viking 1 orbiter when it was scanning Mars. In the region known as Cydonia, it captured what looked like a massive humanoid face, a rocky formation about 1.2 miles long. And this one face inspired books, documentaries, movies, and podcasts. But when NASA's Viking orbiters first took pictures of Cydonia, the cameras weren't super advanced. The image of the face had a low resolution and made the details fuzzy. NASA's later missions had far better cameras, and when Mars Global Surveyor revisited Cydonia in 2001, the truth was undeniable. The face was just a hill, a lumpy rock formation with ridges and depressions carved by wind and erosion. And in 2006, during another mission, a colored image with insanely high detail was made. No traces of face left there whatsoever. That's another pareidolia trick for you. Now, Mars has plenty of secrets left to uncover, but they will be related to its fascinating history, not some secret ancient civilization. The conclusion is, don't trust everything you see online. Sometimes a mysterious rock is just a rock.
Mars can be secretly messing up the depths of our oceans. The red planet is 140 million miles away from Earth, so we once thought that it couldn't have much of an impact on us. But that changed recently with the discovery of some kind of butterfly effect. What starts with a small gravitational pull in space ends up creating giant whirlpools down here. This suspicion began when scientists decided to explore almost 300 deep holes drilled in the ocean floor, which were made back in the 60s. Their goal was to understand the strength of deep ocean currents by analyzing sediments. Materials like sand or mud that accumulated at the bottom of the ocean over the last 65 million years. The bottom of the ocean has layers upon layers of sediments. When these layers show a continuous pattern, it means that the materials have been gradually layering over time without any sudden interruptions. In other words, deep currents were calm and stable. But the researchers also noticed a strange pattern. During specific time periods, they couldn't find any records of sedimentation, which means that something else was interrupting this process. The most likely reason for these gaps was the presence of intense currents at the bottom of the sea. Because they were so strong, they probably moved sediments from their original spots. But here's the weird part. All the gaps identified in the study occurred at intervals of exactly 2.4 million years. The data showed a total of 27 gaps. That can't just be a coincidence. So the scientists realized they were not checking simple breaks in the sedimentation process, they were analyzing the presence of cycles. According to experts, the only plausible explanation for them lies in space and is probably the result of something known as the astronomical grand cycles. To understand this process, we first need to mention the Milankovitch cycles. They're named after the Serbian scientist who suggested a century ago that changes in the way Earth moves around the Sun and tilts on its axis can affect Earth's long-term climate. The thing is, the movements of Earth can be affected by many things, including other planets. Normally, our planet's orbit around the Sun isn't a perfect circle, but it's pretty close. However, from time to time, this path is directly affected by the gravitational pull of Jupiter and Saturn. So it's kind of like these two giant planets can pull our orbit, causing it to become more elliptical. Variations like this can affect the amount and distribution of sunlight, changing the climate here on Earth. According to the Milankovitch theory, Earth's climate patterns change in cycles of 405,000 years, 100,000 years, 41,000 years, and 23,000 years. And the theory is that these cycles might trigger the beginning and the end of glaciation periods, also known as ice ages. His theories were actually confirmed in the 70s by scientists who were also looking for evidence of these cycles in ocean floor sediments. Recent calculations have shown that besides the Milankovitch cycles, there are climate changes that follow much slower rhythms. They don't change every tens of thousands of years. Nope. We're talking about periods that stretch out over millions of years. And this is exactly what the astronomical grand cycles that I mentioned earlier are about. We know about such events basically because of evidence based on mathematics and computer modeling. But it is really hard to find any geological proof of the existence of these million-year astrological cycles, or any clue of how they affect Earth. That is, until now. Turns out, what scientists found at the bottom of the ocean could be just the proof we needed. And that's because the 2.4 million period lines up exactly with records of interactions between Earth and Mars. As the two planets chart their orbital paths, their gravitational fields interact in a process known as resonance. Yep, exactly like what happens with Jupiter and Saturn. From time to time, the gravitational forces of the red planet pull our orbit a bit closer to the Sun. And just like the shorter Milankovitch cycles, this grand cycle also affects our climate. In this case, by increasing the solar radiation that reaches Earth, making our planet warmer. To be honest, experts believe that this amount of extra solar radiation that Mars can somehow give us is not that big of a deal. I mean, it's not going to make our planet so hot that it will make us feel like we're stepping onto the Sun. But this slight difference in climate can be enough to change some behaviors on Earth, such as ocean currents. Warmer climates tend to produce more frequent major storms, and that often produces sediment-stirring eddies, also described as giant whirlpools, which can reach the seafloor at the deepest parts of the ocean, known as the abyss. Finding those gaps in the deep ocean sediment record is really impressive because it's probably the strongest evidence we have of the astronomical grand cycles. As I mentioned at the beginning of the video, it's all like the butterfly effect. Every 2.4 million years, Mars's gravitational pull shifts Earth's path around the Sun, causing our climate to warm up. And when the planet is warmer, it can lead to the formation of large whirlpools, which end up turning the deep ocean waters upside down. And there's one more thing. The cycles found in the research also line up with already known periods of warmer climate throughout world history, like the famous Paleocene-Eocene thermal maximum. This event took place around 56 million years ago, when Earth was warmed by about 14 degrees Fahrenheit. Loads of theories have popped up trying to figure this out, like a glitch in Earth's orbit or maybe the passage of a comet. But with this new study, it looks like Mars could also be involved in this event. These new findings are pretty convincing and exciting, sure, but scientists still need to do more work to link these possible cycles of climate change with deep-sea currents. I mean, they did a good job of finding an explanation for the sediment gaps, but so far, it's just a suggestion. Their success is really important for the whole scientific community, though. After all, knowing when exactly these astronomical grand cycles happen and how they affect Earth can help us a lot, especially to differentiate when climate change happens due to a natural event and when it occurs due to human intervention. Studying these whirlpools can also provide scientists with crucial insight into how climate change affects ocean circulation. So, another reason why this finding is so crucial has to do with the potential collapse of the Atlantic meridional overturning circulation. In short, this is a system of ocean currents that circulates water within the Atlantic Ocean, being responsible for bringing warm water north and cold water south. This is what brings warmth to different parts of the globe and also carries nutrients necessary to sustain ocean life. However, there are some fears that this system might stop or become too slow anytime soon. If that happens, oxygen-rich surface waters would no longer mix with deeper waters. But the good thing is that this possible link between Mars and Earth gives a positive take on this situation by suggesting that in a warmer world, more intense deep ocean currents may prevent our seas from stagnating. But again, it's just a suggestion. The evidence is still thin. Some skeptical experts like to point out that although eddies have indeed become more active over the past few decades, satellite observations have shown that their currents aren't always able to reach the seafloor and maintain an effective water circulation. For now, all we know is that it's hard to say who is right. Only the following studies will tell.
Like the little engine that could, NASA's Curiosity rover has been bravely crawling over Gale Crater on Mars, trying to see what could have happened billions of years ago that made the planet a red desert. And it looks like it might have finally stumbled upon something. While life seems impossible on Mars now, eons ago, it may have been a world more like Earth, with a thick atmosphere, water, and maybe even life. And it seems things changed just recently. Studies show that just 3 billion years ago, the northern hemisphere of Mars might have hosted a stable ocean. On Earth, the Archean eon was in full swing. Volcanoes were going crazy, and life was taking its first steps. Life was also perhaps taking its first steps on Mars. No, not a frozen wasteland like Antarctica, but in a body of water like an Earth ocean. And this Earth-like climate extended Mars's habitable period by about 500 million years more than we thought before. In other words, there was a 500 million years where it was exactly like Earth, with conditions just right for life to start forming. But then, something happened that changed things forever. The atmosphere thinned, Mars lost its oceans, and became the cold, desolate place we see today. It's been a mystery for a while, but now, Curiosity stumbled upon something interesting in the Gale Crater, a vast basin on the Martian surface where, billions of years ago, water once flowed freely. It found carbonates, stuff that can tell us all about the ancient Martian climate. There are minerals that form when carbon dioxide, or CO2, dissolves in water, which means that, to create them, you need two things: a nice thick atmosphere and liquid water. Now on Earth, CO2 is super important because it helps trap heat from the sun in our atmosphere. This keeps our planet warm enough to support life. Plants eat it during photosynthesis to create oxygen, which humans and animals need to breathe. On Mars, the presence of CO2 shows that there really was some kind of climate system. When CO2 starts dissolving in water, it reacts with certain minerals in the ground, like calcium or magnesium, and creates carbonates. That's kind of how seashells form in oceans here on Earth. But instead, it's happening with rocks on Mars. And this discovery is huge. These carbonates act like fossils of the planet's ancient climate. They store information about what Mars was like long ago. By studying them, scientists can get a peek into Mars' past back in the day when water was present. They can tell us how the Martian atmosphere has changed over time, show whether the atmosphere was warm or cold, or if there was a lot of water around, and what happened to the planet in general. Luckily, Curiosity can study this stuff right there. It has the sample analysis at Mars and tunable laser spectrometer. Those are like Mars's forensic tools. The SAM is a mini lab on wheels, and is capable of heating Martian rock samples to extreme temperatures. There are 2 ovens that can heat samples to about 1,800 degrees Fahrenheit. This intense heat causes rocks to release gases trapped inside, the ones that are like ancient fingerprints of Mars, atmosphere. Once they're released, the TLS analyzes them in detail, breaking them down to the tiniest parts. And what the scientists discovered blew away all our previous assumptions about Mars' habitability. Turns out, it's not just about Mars once being wet, but there was something that led to the gradual drying and cooling of the planet. In other words, Mars's water didn't just disappear. It evaporated quickly under extreme conditions. So, what happened to it? Astronomers produced 2 possible explanations. The first one says that Mars went through periods where it was sometimes wet and sometimes dry. The water didn't last a long time. It may have appeared in short bursts, with periods where it would dry up and then return. The second possibility is more intense. The water that was there was incredibly salty and cold, so instead of being liquid, it was mostly frozen in ice. This would have made the planet way too harsh for life as we know it, since the conditions would have been too extreme for anything to survive. Both possibilities sadly mean that Mars wasn't cozy and full of life in the past like some hoped. Well, at least not on the surface. That doesn't mean underground life couldn't exist though. This one is still a possibility. And to find more, we must keep looking for hints of water now. Actually, after years of exploring Mars, scientists have just made a mind-blowing discovery. Deep beneath the rocky surface of the red planet lies a hidden reservoir of liquid water. Real water this time, not the frozen ice caps or vapor in the atmosphere, though it's miles below the Martian crust. This breakthrough comes from data collected by NASA's InSight lander. This guy spent 4 years listening to the subtle tremors of Mars. You know, Mars quakes. And it analyzed over 1,300 of them. Thanks to this, scientists were able to map out how seismic waves move through the planet. And it revealed pockets of liquid water buried 6 to 12 miles underground. Not just one lake, but puddles. So they used the same methods we here on Earth use to find underground water, oil, and gas. And they were able to piece together the Martian underground system. You see, as the water disappeared and dried out, some of it escaped into space when Mars lost its thick protective atmosphere. However, this discovery shows that much of the water didn't disappear. It just sank deep underground, where it still lies today. So close, but out of reach. That's a huge step forward. Water is the most important molecule when it comes to shaping the destiny of a planet. And also, even though we said that Mars wasn't filled with life before, this doesn't take away the possibility of it having life now. If liquid water still exists deep underground, could there be some little microbes hiding there as well? Life as we know it can't survive without liquid water. And now, with this, the idea of life on Mars has become more plausible than ever. There's a catch, though. While this water may seem like a jackpot to future Mars colonization plans, it's not going to be easy to reach. To say that drilling 6 miles deep into the crust is no small feat is an understatement. Just so you know, here on Earth, the deepest we've drilled is about 7.5 miles. It was in the Kola Super Deep Borehole project. And this project pushed current technology to its limits. Intense heat, pressure, equipment failures, you name it. With Mars, that would be even crazier. It has a much colder environment, extremely thin atmosphere, and lack of infrastructure. That would make any drilling mission extremely difficult. To reach water reservoirs buried so deep on Mars, we would need specialized drilling equipment that would somehow get delivered there. It should also be able to handle extreme cold, low pressure, and different gravity. Oh, and it should all operate remotely and preferably not break, all while it needs tons of energy. Yeah. Now, it's possible that we would only be able to do this in the future when we'll have automated systems or astronauts on Mars. That's not a quick task for even the most ambitious billionaires. So, for now, what these reservoirs hide is a mystery. But at least it's not the only one. As we mentioned, Mars hides one of the greatest secrets beneath its frozen southern pole, another buried vast lake of liquid water. The radar revealed it as it scanned the ice cap in this region. Hey, just don't make me pronounce it. Now, it's weird that it managed to stay liquid with such low temperatures. It's probably because of the geothermal heat beneath Mars' surface, and life could be there too. So now they're thinking about probing this lake first. That would be much easier. Curiosity's work is incredible, and it keeps helping us peel back the layers of Mars' ancient climate, giving us new pieces to the puzzle of what happened to our neighbor, and this could help us avoid similar mistakes in the future. Uh-oh. Something is nearing the surface of the planet. It looks like a fireball hurtling closer and closer at a truly incredible speed. Soon, it becomes obvious that the collision is inevitable. Bam! The impact leaves a huge crater. It evaporates thousands of cubic miles of solid rock, and it also sets off a series of terrible natural disasters. Yeah, I know what you're thinking. You believe I'm talking about the catastrophic collision that occurred around 66 million years ago on Earth. You know, the one that's responsible for the extinction of non-avian dinosaurs and 3/4 of other life forms on our planet? But no, the disaster I'm talking about happened on a different planet. Scientists think that our close neighbor, Mars, once experienced the same catastrophe that struck Earth. It happened around 3.4 billion years ago. An asteroid collision might have caused a mega tsunami on the red planet, similar to the one that caused the Chicxulub impact on Earth. Scientists have identified an impact crater on Mars that was probably left by a comet or asteroid collision with the surface of the planet. Most likely, the space body landed in an ocean in the Martian northern lowlands, and the impact was so powerful that it caused a mega tsunami. Before the latest studies, the exact location of the impact crater wasn't verified. It was just a theory. To confirm it, a team of astronomers simulated a comet and asteroid collision in the area where they supposed the impact crater was. They even named this crater Hall. Hall is 68 miles across and lies in a region that is almost 400 feet below the supposed sea level. Anyway, the simulations formed several craters of the same size as Paul. One of the simulations claimed that these craters had been left by a 5-mile-wide asteroid that had encountered strong ground resistance. The other simulation showed that the craters had been caused by a bit smaller asteroid that met a weaker ground resistance. But according to both simulations, the impact crater was almost 70 miles in diameter, and the collisions produced mega tsunamis up to 900 miles away from the center of the impact site. The simulations also helped scientists estimate the height of the tsunami. It was about 820 feet tall, almost as tall as the Eiffel Tower. The authors of the study also suggest that the Pole crater might be similar to the Chicxulub impact crater on our planet. The Chicxulub asteroid, as we now know it, is believed to come from the outer reaches of the solar system. This space body was at least 6 miles across. It crashed into the shallow seawaters near the Yucatan Peninsula. This splashdown was so powerful that it left its signature on the entire face of the planet. In 2021, researchers found out that the collision had carved mega ripples into Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists remodeled the events of the first 10 minutes after the impact, and the model showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. That's like 2 Burj Khalifas, which is the tallest construction in the world, stacked one on top of the other. And of course, all that empty space didn't stay empty for long. The ocean gushed back to fill the crater. But in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, Tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. Imagine a 3-story building rushing up to you. No wonder the largest and fastest moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall, which is taller than the Statue of Liberty, and moved at a speed 10 times greater than more distant tsunami waves. But back to the Red Planet. Some experts think that not one but 2 mega tsunamis could happen on Mars. They could be triggered by a pair of meteor impacts that were several millions of years apart. Between these 2 collisions, Mars went through a period of climate changes. As a result, liquid water on its surface turned into ice. In other words, the first asteroid impact most likely produced waves composed of liquid water, and the second tsunami was probably formed by rounded chunks of ice water. By the way, the largest asteroid to have ever crashed into Earth might not actually be the one that ended dinosaurs. A much more catastrophic collision likely happened about 3.5 billion years ago. New evidence scientists found in northwestern Australia suggests that the asteroid I'm talking about was 12 to 18 miles across. It struck Earth at an immense speed, releasing an unimaginable amount of energy. Now, this made me think, what if something like that happened these days? More than 30,000 objects that are circling Earth these days could potentially crash into our planet. NASA considers around 1,500 of them to be potentially hazardous. These space rocks are the remains left after the solar system was formed some 4.6 billion years ago. For example, in 2004, astronomers discovered a huge asteroid nearing Earth. The first observation showed that the chance of the space rock hitting our planet was less than 3%. The asteroid was named Apophis. It's more than 1,200 feet across and weighs about 20 million tons. It's supposed to streak across the sky on April 13, 2029. Apophis will pass at a distance of 19,000 miles away from Earth's surface. But even though this space rock might miss our planet in 2029, it doesn't mean it won't return 15 years later in 2036. If such an object hits our planet, the consequences will be unpredictable. They can vary from shattered glass and broken windows to most life forms getting wiped off the face of the Earth. And it'll probably affect the internet. Now that last thought is truly scary. But luckily, modern technologies are likely to help us avoid any catastrophic consequences. Experts have developed several ways to prevent a real-life disaster movie from happening. For one thing, we could use a spacecraft to knock this visitor from outer space off its course. Or it could somehow be blasted into pieces. Scientists could also slow the thing down with the help of concentrated sunlight. Or people could tug it away with a gravity tractor. That's a theoretical spacecraft that can influence objects in space without touching them. In sci-fi movies, a huge asteroid often sneaks up on Earth and turns out to be a nasty surprise to astronomers. It hurtles toward our planet at breakneck speed and gets discovered just weeks or even days before the collision. In reality, scientists are constantly watching all large objects in Earth's neighborhood. It means there would be plenty of time to do something before the inevitable happened. There are 3 kinds of missions scientists could prepare at short notice. Type 0, when a heavy spacecraft hurtles toward the intruder with one single goal: to knock it off its course. In this case, astronomers would have to rely on the already available information. The Type 1 mission would involve a scout. It would be launched first to get more close-up information about the space rock. Only after that, the main spacecraft would be launched. With more precise information, its journey would be way more productive. And if scientists chose the Type 2 mission, they would send a scout and a small spacecraft at the same time. The spacecraft would knock the asteroid a bit off its course. Then the scout would collect all the necessary information. Based on this data, the spacecraft would finish its job with a more fine-tuned second push. If none of these methods work, people could try going deep underground or even build a shelter on the ocean floor. But in this case, we'd need to find sources of energy that could help us survive for at least several decades. Plus, people would have to create a life support system that could somehow keep air and water fresh.
Mars is the Earth's space cousin. It's the fourth planet in our solar system, about half the size of the Earth. It also has two small moon buddies, Phobos and Deimos. These moons are shaped like potatoes. Phobos is the drama king, moving closer to Mars and planning a crash landing in about 50 million years. Deimos is much calmer though, hanging out farther away from Mars. Mars got a cool nickname, the Red Planet, thanks to its rusty red surface. This color was so bright that it was spotted by astronomers many years ago. Even you can sometimes see it in the sky with the naked eye, a small scarlet dot. And maybe it has hot vibes, but in reality, Mars is a very cold desert. The temperatures there can drop as low as minus 240 degrees Fahrenheit. But was Mars always nothing more than a rusty-looking desert? Actually, no. Scientists believe that perhaps many years ago, this planet was similar to ours. Meet Curiosity, the detective rover made by NASA's Jet Propulsion Laboratory. Scientists want to know all about the Martian weather, landscape, and other stuff like that. Curiosity is a pretty heavy car-sized robot. It weighs about 1,985 pounds. It embarked on its journey on November 26, 2011. The rover pulled off a landing on Mars on August 6, 2012. Originally, Curiosity's mission was supposed to last for 2 years, but it's still going strong. Curiosity is basically a space lab on wheels. It's packed with cameras, spectrometers, radiation detectors, and sensors to sniff out the Martian environment. As Curiosity roams around, it rewinds Mars history. And during its mission, the rover discovered something incredible: signs of lakes and rivers from long ago. You see, Curiosity's favorite spot to play around is Gale Crater. It's a prehistoric Martian oasis where water might have hung out. There's this huge mountain in the middle called Mount Sharp. This place is taller than 10 Eiffel Towers stacked on top of each other. And it's got layers of rocks that hold Mars's ancient secrets. Recently, scientists spotted something great when studying Curiosity's data: mud tracks. What's so surprising about that? Well, these aren't just any old tracks. They're like messages from the past. They mean that the Martian ground used to get wet and then dry out again. The mud on the ground would shrink and crack during the drying phases, making these T-shaped junctions. Moreover, it seems like the ground on Mars went through several wet-dry cycles. It happened maybe up to 10 times. This made the junctions turn into Y-shaped cracks. When a bunch of Y-shaped cracks got together, they made a super cool pattern, something like a patchwork of hexagons. It looks just like honeycombs, or even a dragon's skin. Each of these hexagons are the size of candy. Similar cycles have happened on Earth, and they're linked to the birth of life. When water dries up, it leaves behind concentrated stuff that's great for chemical reactions, and these reactions might be the same ones that kickstart life. These hexagons have been hanging around for a really, really long time, billions of years. That means that Mars once had a climate kind of like Earth's, and maybe even life. In fact, the Red Planet even has some signs of water right now, in the form of hidden ice at the poles. Mars has the North and South poles, and just like with the Earth, they're Red Planet's ice caps. Picture the North Cap as a big, icy pancake about 620 miles wide. The South Cap is a bit smaller, about 220 miles wide, but it's got a thicker ice layer, almost like a snowball with a strong shell. When it's winter at the poles, it's an incredibly long nighttime. No sunlight, just chilly darkness. During that time, around 30% of the air turns into frozen CO2. It's dry ice, the same stuff that's often used in horror movies. But when the poles wake up to sunlight, the dry ice turns back into gas. All this freezing and thawing makes clouds and frost, just like on Earth. One time, a rover named Opportunity even caught some clouds made of water ice. But it doesn't necessarily mean Mars was once thriving just like the Earth. Life needs more than just wet, dry cycles to pop up. It needs the right atmosphere and other special ingredients. We're not sure if Mars had all of those, and even if it did, there's no guarantee that life actually happened. But this raises another very important question. Has Mars ever hosted tiny living creatures? Curiosity isn't the only robot that tries to find the answer to that. There's also a rover called Perseverance. It's trying to find clues about Martian life. It's digging into an old Martian crater once filled with water. And like a space archaeologist, Perseverance is searching for fossilized signs of ancient critters. And here's the funny thing. Some scientists think that we've stumbled upon it almost half a century ago. The only problem is, we might have accidentally destroyed it. It happened even before Curiosity started rolling around Mars. Back in the 1980s, two cool NASA's landers, Viking 1 and Viking 2, made a pit stop on the Red Planet. These landers took a selfie, and then they also did some funky experiments on the Martian soil, all in the name of finding signs of life. What they found is some weird organic stuff called perchlorate. It's a compound that we use in fireworks or rocket fuel. But most results didn't seem that promising. They even mixed up some soil with water and nutrients, hoping that if there were Martian microbes, they'd snack on the goodies and return radioactive gas as a result. But unfortunately, that didn't happen. Now, here's the problem. Some scientists think that maybe the water they added back then actually destroyed those tiny Martian critters. Poor microbes were just hanging out and suddenly got soaked by a bunch of weird liquid. Something like this wouldn't be very pleasant for the Earth microbes. They live inside rocks and they're sucking water from the air. Pouring water on them would result in a total disaster. So, of course, giving them nutrients after that wouldn't do anything. If you've just barely survived a water bath, you're probably not in the mood for a feast. Perhaps these Martian buddies might have something called hydrogen peroxide in their cells. It helps them live in an extreme environment. If that's true, it could explain all the results from the experiments. You see, the instruments heated up the samples, so if there was hydrogen peroxide, it would have gone boom, wiping off the little guys and turning their cozy homes instantly. Imagine how ridiculous it would be if it turns out that we accidentally destroyed the only signs of life on Mars. Ideally, we need a new mission to Mars to test this theory. Let's hope it's not true. In any case, the journey isn't over. There are more missions planned for Mars, and humans might even visit this planet someday. The next mission is the Mars Sample Return. It's a super cool teamwork project between NASA and ESA. They're teaming up to bring back souvenirs from Mars, collected by NASA's trusty Mars Perseverance rover. There's going to be a whole bunch of spaceships. They'll work together to bring these precious Mars samples back. The samples are planned to arrive on Earth in the early to mid-2030s. And the fun doesn't stop at Mars. Our Mars missions are a warm-up for an even bigger adventure, exploring icy moons around Saturn and Jupiter. These moons have hidden oceans beneath their icy surfaces, and who knows what kinds of space secrets they're hiding. But whether it's Mars, icy moons, or beyond, our quest to find extraterrestrial life continues. In addition, we are slowly starting to find more and more organic materials on Mars, and maybe one day we'll finally find some microbes in our solar system. Let's hope for it, and stay tuned. We just can't get enough of Mars, can we? Everyone wants to go there, and astronauts are now looking at caves on the Red Planet where they can live once people inhabit it. The planet itself has some similar characteristics to Earth. Yeah, it's somewhat smaller than Earth, but the time it takes for the planets to revolve around themselves is also similar, which is about a day. On paper, Mars might seem like a good idea given some similarities to Earth, but there are some factors we need to pay attention to before we consider stepping foot there. The temperature. Mars might look like a scorching hot planet like a freakishly large Sahara Desert, but quite the opposite. It's really cold. Mars has a reputation for being a freezing, desolate, endless land that happens to have the largest mountain in our solar system thus far. So, within those mountains, astronauts and scientists are considering whether naturally built caves are the answer to our survival. Caves won't be the worst thing we'd live in, considering our ancestors used to dwell in caves in communities. Logically, it's the best place to stay dry during a storm and keep warm. It's the best place for protection against predators like giant birds, elephants, and saber-toothed cats. We even had our first art shows in caves with evidence of cave art dated thousands of years ago. Caves are a good idea, and they can also help us save a lot of money when establishing a colony on Mars. Rather than building a fresh structure in the middle of an open plain, the cave structure will help and influence the architecture, potentially saving lots and lots of money. Going to Mars will be expensive. It's already expensive sending people to the moon and launching a rocket into space. So, we have to consider the logistics. Another thing to look out for is caves in the ground that are not necessarily stuck on mountains. Scientists believe that most potential places for humans to thrive are caves. These spaces are large enough to host large populations. So far, they identified 9 caves as large as football fields. So what would life look like if we lived in caves on Mars? For one thing, sunlight would be hard to access. By the time we reach Mars, we would have the best technology to maximize our lifespan in a hostile environment, which means withstanding the harsh sun rays of Mars. Most likely, we would dig through the caves further underground where oxygen would be pumped for everyone to breathe. People can walk around casually, thinking they're on Earth, and to exit the caves, you would need to wear a special suit. These cave colonies would have dormitories for people to live in and special spaces for colony meetings, entertainment, grocery markets, schools, and other places that are needed to sustain a colony. There would also be indoor farms to grow crops and raise livestock. A team of experts mapped out what some of the dwellings will look like on Mars. And just like on Earth, we will have apartments for young professionals, family homes, and luxury mansions. Some of the dwelling units would be placed on the surface and not in caves. One of the key elements of the design and architecture is how to build it around the natural light to brighten up the homes. Another element is how to deflect radiation and cosmic rays. Because Mars has such a thin atmosphere, sun rays and other hazardous objects easily enter Mars. The dwelling units also have to be sturdy to protect them from severe dust storms and extreme cold temperatures. Some of the living pods or dwelling units that are for couples or singles would have tunnels leading to a shared workspace and garden. Studies show that even being in the presence of greenery can reduce stress levels significantly. And on the red planet, we would definitely need some greenery. We can expect the family homes to be built within the caves, not necessarily underground. It would be tempting to head outside with the view of Mars, but the large thick glass would prevent anything from coming in and out. Those who are underground with a view rely on LEDs and camera systems to screen the surface landscape of Mars so it acts like real windows. And if you're bored of the surface, you can always switch the channel and watch something else as you please. Maybe a flowing river surrounded by trees. Or maybe a penthouse view of all of New York. The choice is yours. There would be a driveway that leads to a garage so one can enter and exit easily. There won't really be a reason to exit the cave colony except probably to visit other cave colonies. In this case, we would have highly crafted vehicles that will take people from colony to colony on the surface. The vehicles can withstand harsh temperatures and would be constantly transporting people daily. Some people might live in a certain colony and have to commute to work every day in other colonies. Humans might not have to be working in dangerous conditions or on the surface. We would have robots that will do that for us. The thing about robots is that they don't need to be human-shaped to do a job. However, before transporting humans to space, we would need to create some human-like robots and land them on Mars. With the exact physical form, we can determine what would happen to people if they were on Mars. We would have robots for specific tasks, helping us with everything. Let's not forget artificial intelligence plays a major role in monitoring the systems and updating the functionalities of the colony. It'll know when certain systems need fixing, adjusting, renewing, and changing. We also need people to keep an eye out for anything out of the ordinary, and also to make sure people are behaving and not breaking the law. Getting to Mars would be the earliest obstacle we will face. We've already launched some robots to explore the terrain and conduct some studies. At first, we would send robots to test the conditions and to build most of the infrastructure. To build a proper colony, we would have to send out young couples willing to dedicate their lives to the future and the future of their children. It won't be easy. In fact, there would be a variety of people with different professions and specializations to help establish the colony. People would have to work and establish a local economy. We would need scientists, doctors, farmers, teachers for the children, and engineers to maintain the structure. It will take time for the colony to reach a substantial size, but it's all part of the process. Even the spaceships would need to be large and sufficient to house thousands of people traveling from Earth. Of course, by then, most of the dwelling units would have been built, and people would have already picked out their houses, depending on if they were single or if they were about to start a family. Once the colony has the necessary professionals it needs, then come the other people who wish to start their life on Mars. People would need entertainment, so musicians would find a place in the colony. We can't expect everyone to go out on a nice sunny day to the beach, but perhaps one day, when the colony is large enough, there can be an artificial body of water with the same elements as the beach. Livestock animals would also be shipped from Earth to be raised on Mars, where they can populate for our nourishment. We can also bring most of the animals and establish a wildlife sanctuary for everyone to enjoy and for the animals to thrive. For now, humans are planning on reaching the Red Planet sooner than we think, and who knows, maybe you can be one of the first people to sign up and have your own little dwelling unit far away from Earth.